draw a net for the figure. So if you take a box from Amazon, that is 3D box. So when you flat out all the faces, that is a net. Okay. So let's see over here. If you see your box, if you open your box, or you can count. You can count. Take a box. Do I have a box here? I have a box of chocolate. Ooh, I have the box of this. Um, this is the box of cable modem router. I try to improve my internet, so I order the internet from Comcast Xfinity. So look at this box. You can see you have 6 faces. All right. So when you flat them out, you should have 6 faces, 6 faces, and then when you put them back, you should be able to put them back together. So let's see over here. This one has 6 faces. Okay, so this is the correct answer. And then when you line them up, these 2 edges, you can line them up together. All right, over here, you can line them up. This one has 6 faces, but when you line them up and put them back, you can, because this one is, I don't know, it's just smaller. Okay, so that's why option C should be an option. And option B is not correct because you have 7 faces. 1, 2, 3, 4, 5, 6, 7. You cannot put them back. Okay, so that is a question A. All right, and then let's go to maybe one more. One more. Okay, very straight. Oh, I like this one a lot. Okay, let's clear this, and I choose a similar. Okay. What do they tell you? Make an isometric drawing of the cube structure on isometric dot paper. Okay, so let's do one by one. You do the front, okay, and you do the right, and then you do the top. Okay, so let's do the front first. Okay, so when you do the front over here, you see that this is what you see, the front right there. So you got this one, you got this one, you got this one. So far so good. All right. Do you also see this one and then this one? But then notice over here, because it's these 3 faces on different level. So when you look into the front, you should see. So let's do it for now. Okay. So this one go with this one you don't have it. So this one wrong. This one you got it. Okay. This one you got it. All right. Here we go. Now up here one more. Okay. So let's do this one. Okay. This one. Oh, this one we will eliminate. So this one good. All right. Now let's take a look at the from the right. From the right. All right. Here we go. Um, Oh, here from the right. So let the pen, get the pen over here. Is that right there? Okay. This one right here. All right, right here. And this one right here. 2 of them. So 1, 2. Okay. Let's do the one on top also. 1, 2. This one look like 1, like 3. So this one now is incorrect. Okay. This one should got 1 right there. So this is not correct. Oh, we already not correct. So this one you got this, this, and then this. And then this one is here, and then at different levels. So this one is wrong. So the correct answer is D. Okay, here we go. From the right side, that's what you have. Okay, so but for the sake of it, let's do from the top. From the top. Okay. You look down, you see this. Okay, so that's a go over here. You look now, you see that. That's over here. And then over here, you got that. All right. Okay, so that's how you view 3D. So I took option D over here. Let's do one more. One more. Let's clear this out. This way, go one more. This one, 9. Okay, this one. Okay, this one. Let's do a similar. Okay, so let's do the front. For the isometric drawing, make an orthographic drawing. Orthographic drawing, you have the front, the right, and the top. Okay, assume no hidden cubes. Okay, so let's do from the front. Front first. Okay, here we go. So that when you look this way, that's what you see. Okay. So when you look, and you can see the front had different level. So between the three square it had to be had the break line right there. Okay. So far so good. The C, the B it cannot be because you have no break line right there. It's supposed to have a break line. Okay. The A, correct. Okay. So now let's do the right side. It's the right side. So look this way. Okay. Again, these three faces right here in different level. So it should have the break line. This one had no break line right there. Okay, so this one is wrong now. So this one is correct. Okay, 1, 2, 3. All right, for the second it, let's do the top. The top right here. That's what you have. Okay, so and that's what you have. Okay, here we go. Option A is correct. Done. So this is fun. This is fun homework. So for those of you who never try, could try it, you guys, because all your friends got 100% for this. All right, let's move on to the new lesson of the day. And then you take your test tomorrow. Okay, let's go and get the lesson. Here we go. Google Classroom. Google Classroom. Here we go. Okay, here we go. Okay, this one, space, figures, and cross section. So now we learn things in 3D now. Okay, and make it bigger, bigger. Oh, this is a pyramid and this is a prism. Okay. Here we go. Um, they give you definition. Polyhedron is a space figure for three-dimensional figure whose surfaces are polygon. Okay. Surface is polygon. So you can see this one is not because it's the circle. This is a circle, and the bottom also circle. So this one is not a polyhedron. Okay. Um, this one is prism. If you want the name, it's triangular prism. This is a pyramid, pyramid, and this one rectangular prism. This one you call triangular prism because here you go. These two faces, they are a triangle. And over here, you can choose the top and the bottom face, whatever you want. You can choose this one is the top, this is the bottom. This is how you view the box. So this one also called prism. Prism. Here we go. Anything about lesson today? Let me roll down. Here we go. Ooh, this is fun. Euler formula. Euler formula. Over here. Here we go. So remember, this is 3D, okay? So the sum of the number of faces add with the number of vertices is 2 more than the number of its edges, okay? So I think we should go directly to the homework and then we do it from there. Okay, here we go. Let's pull out. Here we go. Because you have different formula for 2D. 2D, it means you flat them out. So 3D, So this is 3D, okay? So they ask you how many vertices? How many vertices? Vertices, this is vertices, okay? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is called vertices. Vertices. Okay, so make sure you list them out. IJST, IJST, and then UFWH. All right, I would choose option D over here. Okay, very easy to keep track. IJST, and then UFWH. Okay, so I would choose that option D. Bam, 8. Should not be 7. 8. All right, what else did they ask you? How many edges? Okay, edges over here, you can count. Let's count it. 1, 2, 3, 4. So 4 edges on the top. 1, 2, 3, 4. So 4 edges on the bottom. Do not forget the sideway. 1, 2, 3, 4. So you got 12 edges. Okay, so let's see over here. Let's see the answer. 12. 12, you got 2 of them. So which one is correct? Let's see one by one. Let's clear this out for a second. So could be this 12, could be this 12. Okay. The first one they get IJ, okay, IJ, JS, okay, ST, okay, and then IT. All right. So far so good. UF, okay, this is UF, FW, okay, WH, and then UH. All right. So far so good. And then the last 4. IU right here. IU, JF, okay, and then JF, SW, and then TH. Okay, so option B is correct. Here we go. Move on to the next question. They will ask you faces. Okay, how many faces do we have for this prism? This is you have 6 faces. Okay. 2 on the top and the bottom, and then 4 surrounding. Okay, 4 surrounding. 1, 2, 3, and then the front. Okay, so 6 faces. So which 6 faces is correct? So let's clear this out. Let's count. Here we go. Let's take a look. 6 faces. Okay. The first one, IJFU. IJFU. All right. Choose this one. The next one is STHW. STHW. Okay. Also, so the next one is JS. JS. JSWF. All right. So I have the feeling this one correct. And so that in the back. What did I miss? This one is FW, maybe you different color. Where's F? FWHU. So that's the bottom one. Okay, this one IT, and then HU. So that's the front. Okay, I think I missed one. Maybe it's this one. All right. IJFU. ST. Yeah, we count everything. TS, ST, FTHW. So that's the one on the right side over here. That's over here. Okay, so option B is correct. Check the answer. All right. Let's find out why option C is incorrect. All right. So let's see over here. This is also 6 faces, but why is incorrect? IFJG. IF. You see the way they count it is crossing. You can't do that. So IF and then JU. So when you name a face, make sure you go with the order, like this one over here. Okay. IJU. FU. So that is correct. The way they count over here, that's incorrect because it's crisscross. All right. Zigzag. So I would not. So that's why the option C is incorrect. All right. So we're done with question number 1. Move on to question number. Oh, number 1. Did we do number 1? Oh, this is one number 2. Okay. Number 2. Here we go. So now, we just apply the Euler formula that you see second ago on your lesson. Okay, the number of faces add with the number of vertices equal the number of edges add 2. So this is 3D, okay? Because later on you will see the 2D formula, okay? So now, look at over here. The faces, we don't know. So put it F. The edges, we got 11, okay? Vertices, right here. Vertices number 8, okay? And then this is plus 2. So we know the answer. So we solve for this. So this is come out 13. So F plus A equal 13. So I subtract A on both sides. So F equal 5. So you got 5 faces. Okay. 5 faces. Put right here. Done. Okay. For the fun of it, let's go and try to find polyhedron. Polyhedron. Did I say it correct? Math open. Reference. Okay, here we go. Do we have it? Oh yeah, because I want to show you guys how many faces look like. Do I have it here? They don't have it here. They do not have it here. Let's try again over here. Polyhedron. We don't have it. Okay, I can search for polyhedron with 5 faces. So I'm going to show to you what it look like. With 5 faces, do we have the images here? Oh yeah. Oh, this one 5 faces. Okay, you see that? That's 5. Or a pyramid. This one also had 5 faces. You can count front, back, and then 3 surrounding. So that's 5 faces. All right. Move on over here. I see a message. Somebody say something. You guys, you have 2 assignments today. The 2 more assignment is for your test. So ideally, you do all of them. You do what you can, because if you don't do it by tonight, and you take the test and you do it tomorrow, you have less advantage to take your test. But if you retake your test, definitely you have to do your test review. And I give you guys full credit if you turn it late, all right? But ideally, do your best. Um, um, so move on over here. Move over here. Next question. Next question. Let's see over here. Clear this out. Same thing happened. Use Euler formula to find the number of vertices in the given high polyhedron. So when they say polyhedron, it has to be 3Ds, all right? Okay. So 3D formula, faces at vertices equal edges at with 2. Okay. Substitute in faces at A, so I put number 8 right there. Hexagon. 2 hexagon. Ooh, 2 hexagon and 6 rectangle. Ooh, 2 hexagon. As let's see over here. Find the number 2 hexagon and 6 rectangle. So let's write down hexagon right here. 1, 2, 3, 4, 5, 6. Okay. 1, 2, 3, 4, 5, 6. All right. So now This is one. This is hidden in the back. This is in the front. Okay. This one in the back. So it's broken over here. So you can see the top and the bottom are two hexagon. The surrounding, you got 6 rectangle. You see that? One type rectangles like this. 6 of them. Okay. So from here, can you count the edges? Yes, you can. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you got 12 edges. Okay. Um, vertices. No, I did I count it wrong. Number 12, that is vertices, not the edges. All right, so let's erase that over here. The vertices equal 12. Okay. Um, the edges, you can see the edges have to come out how much? A plus 12 is 20. So this is 18, is that right? But you can go and count yourself. You can go and count yourself right here. Here we go. 1, 2, 3, 4, 5, 6. And that count at the bottom. 1, 2, 3, 4, 5, 6. So 6 and 6 and 12, is all right? And now if you count the surrounding edges, edges should be another 6. Okay. 1, 2, 3, 4, 5, 6. So that's why it come out 18. Okay. So vertices, give them 12 first. That 12 vertices. Okay. The next one is, oh, that's it. That's it. Let's do one more of that question. Let's do one more question, number 3. Click on a similar. Okay. 6 faces, one pentagon and 5 triangle. All right. So if you have one pentagon, it had to be a pyramid. All right. The top pyramid up here. Okay. So when you connect it, so let's connect it. Okay. This is the front. Okay. And this one hidden in the back. So I put dash line. Okay. So does it look like it had total 6 faces? Okay, one pentagon, and then 5 triangle. So this is one triangle right here. Okay, you got 5 of them. Okay, so vertices. Let's count it. 1, 2, 3, 4, 5, and then one on top. So you got total 6 vertices. Okay. So when they give you on question number 3 over here, if you have let's click on one more. Let's click on one more over here. Okay, similar. So it will give you one hexagon and then 6 triangle. You know this is the pyramid. Okay. So one hexagon, the vertex of the hexagon, that's 6, and then you do the top vertex. So then you got total 7 vertices. Okay, this one the back, so I should dash line. So that should be 7 vertices. Okay, here we go. Let's see over here. Okay, let's see over here. That's it. I had to remove a bomb zoom. Sorry about that, you guys. Here we go. Let's go back to that. It's annoying why we keep having zoom bomb over here. All right. So move on. Check the answer. Move on to question number 4. Here we go. Let's take a look over here. Verify Euler formula for the polyhedron to the right. Then draw a net for the figure and verify Euler-Muller for 2 dimensions. two-dimension figure. Okay, so over here, let's count faces plus vertices equal edges plus 2. Okay, so let's do that. Over here, um, faces, faces, you got the front and you got the back. Okay, you got the back. So that's 2. And the surrounding, you should got 5 of them, 5 rectangle, is that right? 5 rectangle. I should draw one of them over here. 5. You got total 5. So 2 plus 5 is that 7 faces. Okay. Edges you can count. You can count. 5 in the front. Did I say edges? Vertices. Yeah, vertices. So 5 in the front and then 5 in the back. That's it. So you got 10. You got 10 vertices. Okay. So this one, the edges, this is plus 2. So the edge, so 7 plus 10, that's a 17. So this one had to be 15. Okay, if you want to count, you can see it right here. Let's do this. 1, 2, 3, 4, 5. So 5 edges in the front, 5 edges in the back. So that's 10. And then 5 edges surrounding over here. So you got total 15. So we are correct. All right. So let's go and find which one. 15, 7, right here, the C, option C. You see the option C right here. Okay. 7 plus 10 equal 15 plus 2. And then we're done. Check. Okay, now continue. So spread them out. So a second ago, the number of faces we got is 7. All right, 7. So take a look over here. When you spread them out, this is 7. All right. This one is not 7. This is 1, 2, 3, 4, 5, 6, 7, 8. So this option completely wrong. This option is 7. Okay. 1, 2, 3. Oh, this one only 6. 1, 2, 3, 4, and then 5 and 6. So this is wrong. So this one is correct. This is 7 faces. Okay. So I choose option C. Now you apply the formula for 2D. Euler formula for 2D. Okay. So let's take a look over here. You can find let's find the formula from here. Okay. If I don't mistake, okay, 3D, the formula is faces plus the vertices equal edges plus 2. But for 2D, you plus 1. Okay, 3D is more than 2D, all right? 3D you plus 2, but 2D you plus 1. So let me double check over here. Faces, you still have the same. How many faces? 7. So 7. Vertices, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then 12. 12, 13, 14, 15, 16, 17, 18. So this is 18. Okay. Now, edges, let's count the edges. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20. Oh, the inside 20, 21, 22, 23, 24. Oh my God, you got 24. So 24 plus 1. So I'm correct with the formula. Okay. So again, you guys, if it's 3D, the formula you plus 2. But 2D, the formula you plus only 1. All right. So write down on your note 3D, you plus 2. 2D, you plus 1. Okay, so let's go and find the correct one over here. 7 plus 18, 24 plus 1. Okay, so that should be option B right here. So I choose option B and then I'm done. Okay, next question. Next question. Here we go. Describe the cross section in the figure to the right. Okay. Does it look like a donut? Donut. The cross section is a donut. The cross section is so it's like you got a 3D figure and you use a knife, you cut through it. The cross section is definitely not a rectangle. It's not a line. It's a donut. It's a circle. Actually, it's two circle. Why they said only one circle? I would you the D is it looked like the D. The D is a bad choice. Okay, let's choose and see what happened. What happened? Determine try to mentally rotate the solid so the plane is parallel to the face. Then identify the face the plane had cut out. So when so let's rather donut. This shape is look like a donut, and then you. Oh no! This shape is what happened? Hmm. I cannot really see clearly. Uh, over here. Hmm. So the option had to be C, but the picture is not clear to me. Let's do a couple more over here, similar. See what happens. Oh, this one is easier. All right. So this is like a cone, the traffic cone that you have. Okay. So when you have a knife, you cut through it. When you connect it here, this one it should be a triangle. Okay. So that's a triangle. So let's clear this. It had to be a triangle. Okay. Triangle over here. Next one. Oh, let's do it again. Let's do a couple more. Let's do a couple more. We have plenty of time. Gotta clear this. Uh, Havela Westry. Do we have Havela Westry in this class? Let me see. Give me a second. Oh, I can take a look over here. Havela Westry. Are you in this class right now or are you running late? Havela Westry, are you here? Okay, she's super late. Okay. You guys, if you are this late, I won't let you in anymore because due to the Zoom bomb. Okay. Hopefully she's not a Zoom bomb. Havela. Havela, can you hear me? Havela. Let me see, she says something. Okay. Okay. If you can't come late like this, I won't let you in next time. Should let you know. Because people try to bomb this class. Okay, let's see over here. So that's a triangle. Let's do one more similar over here. So this is the prism, or we call it a box. So when you cut, or you can imagine like this. This is like a chocolate order, um, chocolate that you order from the restaurant, and then your mom take a knife and she cut. When she cut out this cross, this cross surface had to be a rectangle. Okay, rectangle. Here we go. Done over here. All right, let's do next question. I see a message over here. Okay, sorry about that, but I would like panic. There's a bomb, Zoom bomb that make funny noise. Okay, draw and describe the cross section formed by a plane intersect a cube as follow. Okay, the vertical plane contain the red edges. Okay, if it contain the red edges, it have to be this one. Is that right? The red edges right here. Okay, so had to be option C. Okay, clearly option C over here. Okay, here we go. What happened? The cross section had to be, if you take a look at your cross section over here, here we go. Is that a rectangle? Yeah, it is a rectangle. It cannot be, yeah, it can be a square, but sometimes, so you have to choose the option that it happened most of the time. So I choose rectangle. All right, question 7. Question 7. Over here, oh, this one, pay attention. There's a little hole. So this one, how would I describe this shape? But it cut right on top over here. Okay, so inside it had to be a hole. Okay, so the answer would be this one. The reason right here. So actually, this one give it away. Look at the top face of the shape over here. All right. Does it? So when you use a plan that parallel and cut, the shape come out should look very similar to the top face right there. So the answer had to be C. Okay, C. Okay, and if you notice, there's a little hole inside. There's a little hole inside too, and because you cut above that point, okay, above that point. So that's why you got the hole inside here. Then the holes happen to be a square in this case. All right, continue over here. We have 5 more questions. What happened? Oh, so the first way you cut horizontally. Now the second way, option B, you cut it vertically. Okay. So when you cut vertically, imagine you have a plan like this, like you have a knife. You cut it down. Okay. So you want to cut through this. I would choose option. I would choose. Depends. Hold on. Sketch a vertical cross section contain the vertical line of symmetry. Oh, so symmetry you have to cut right in the middle. Okay, so when you cut right in the middle, right here, it should come out option A. Okay, you cut right in the middle over here. So here we go. So you cut right through the middle. The line of symmetry contain the line of symmetry. So right in the middle. Okay, so I choose option A. Done. Let's do this question again. Let's do this one again. Here we go. All right. Now horizontally, so we cut through. Do we have a dessert look like this? So it had to come out this because look at over here. There's a hole inside. Okay, so when you cut it, the hole is still there. Okay, so that's option C. Now you cut vertically. Okay, vertically. Uh, the vertical cross section that contain the vertical line of symmetry. Okay, so look at over here. When you cut that contain the line of symmetry, the line symmetry actually the line that go through this cylinder go through inside. Here we go. So when you cut like that, it had to look like this. Okay, it look like that. So that would be have to be the C. Done over here. You got 5 more questions, and then we done. Okay. Oh, this is fun. This is fun. Let me show it to you. I have the flag. All right, here we go. So look at my flag. My flag is not a triangle. Okay, my flag is rectangle. Okay, so when you rotate the flag, one revolution, it means one circle. Is that you come out a cylinder? Okay, you come out a cylinder. But this time the flag is maybe I can do this paper. The flag is a triangle. So let me fold a triangle right now. Here we go. So here we go. So this is triangle. It looks like this. Okay. So when you rotate, does it look like what? Okay. When you rotate one one revolution, does it look like it come out as a cone? A cone? All right. So let's see right here. When you rotate this point, pay attention to this point. If you rotate half a revolution, it means half circle. Is that go down here? Okay. And then you continue to rotate a full circle. So that's how it looks on the base. Okay. So now it become a cone. So the answer had to be a cone. A solid revolution is a cone. All right, here we go. Is a cone. Let's do this question again. Okay, similar. Oh, it's still a triangle. So when you rotate the triangle along this line L, okay, again, half circle, go down here, and then full circle, you go back here. All right. So that's the base. And this point, when you rotate on the line, it doesn't move anywhere. Okay. So when you connect it, it turns out it's a cone. It is a cone. Here we go. Oh, this one. You see the formulas right here? This is a 2D formula. So you only plus one. Only plus one. Here's a formula. So that is a 2D. 2D. Okay. So let's see over here. Apply two-dimensional network where F is the number of regions formed by the T vertices by V vertices linked by E edges. All right. Let's see over here. Let's count the number of vertices. 1, 2, 3, 4. So edge is 1, 2, 3, 4. So it had to be option A or option D. Okay. Faces, you got 2. 2, 1, and then 2. All right. So this had to be here. And then you want to count the edges. You got 5 of them. 1, 2, 3, 4, 5. Okay. So the correct answer had to be D. D. All right. So this is 2D, you guys. It look like 3D. It looked like a ball upside down, but they said 2D. So 2D. Okay, let's do this question one more time. One more time over here. All right. Let's count the faces first. 1, 2, and then one more in the middle. So 1, 2, 3. So faces have to be 3. That's a 3. All right. So it can be option A, can be option C. Now let's do the vertices. Vertices. 1, 2, 3, 4. 1, 2, 3, 4. It had to be option D. Okay, 1, 2, 3, 4, right there. Option D. Okay, let's count the edges. Edges. 1, 2, 3, 4, 5, 6. All right there. So option D is correct. Okay, the cube had a net area. How long is the edges of the cube? All right. So the cube, here's your cube. All sides equal each other. All right. Do we have a rubric cube? I don't. I used to have in my class. Okay, let's draw a cube over here. Okay. So a cube is you got 6 faces and they all exactly the same. They all square. Okay, 1, 2, 3. Okay, it's inside, so I draw a dash line. Okay, so the net area, it means you add net area, you add all faces equal each other. Is that right? So equal net area equals 6 times face area. Face area. Okay, because each face exactly the same. All right, and the measure of the length of each edge, let's call it x. Let's call it x. Okay, so all the edges, the length is x. Okay, x. So if you want to find the area of one face, is that x times x? Okay, so net area equals 6 times face area. Okay, so let's write over here. Net area equals 6 times face area. Okay, net area, they give it to you right here, 384 equals 6 multiply each face is that x times x. Okay, so now I have to divide 6 on both sides. I divide 6 on both sides. So now the left side come out 64. 36, 64. Yeah. X times x equals x squared. So if you want to find the x, you take the square root of 64. Is that the x had to be equal 8? That's it. That's your answer, 8. Okay. And then we're done. Let's do this question one more time. All right. Anthony Anderson. Anthony Anderson, are you here? Anthony Anderson. All right. I guess he's not here. So now they give you the net width area is 600. So I go over here. Maybe let's clear out the whole thing. We can do it again. So let's draw a cube. Okay. So here's a cube. Inside, I do dash line. All right. So you have a 3D. So each edge is x. Okay. So the net area, so you add 6 faces area together, and they each of them exactly the same. Is that right? X times x. So 6 times one face area. Okay. So net area, they give you 600. So I put in 600 equals 6 times. Each face area is that base times height, and they happen to be the same. So is that x times x? All right, I would divide 6 on both sides because I try to solve for x. So I come out 100 equal x times x, is that x squared? So if you want to find the x, you take a square root of 100, come out 10. 10 times 10 is 100. All right, so 10, and then you're done. All right, let's do the last 2 questions over here. The last 2 questions. Draw a plane intersect a cube to get the cross section indicated. Okay, a parallelogram. Okay, remember parallelogram? 2 pair of opposite sides had to be parallel. So here's your cross section on the first one over here. All right. First of all, this shape has 5 sides, so it's not a parallelogram. Parallelogram have only 4 sides. This is a pentagon. So this option is incorrect. And this option over here, the cross section had 3 vertices, so that is a triangle. Okay, so it leaves you only option C. Okay, so if you have a piece of chocolate look like this, and you use a knife to cut this way, and then you will see the cross section is a parallelogram. Okay, so option C. Option C. Here we go. So question 11. We have so much time. Maybe I should do question 11 one more time. Oh, question 12. Very similar too. So, okay, we might finish early today. Draw a plane intersecting a cube to get the cross section indicated. Equilateral triangle. Okay. Equilateral triangle. Okay. So you see this one over here. This is a cube. So 6 faces exactly the same. So when you connect one vertex to the opposite vertex. This is diagonal. This is the diagonal of one one face. Okay, and all the faces equal each other. So three diagonal exactly the same. Okay, so this option is correct. You can see this option is not correct. The three sides of the triangle are not congruent. Of course, this one not congruent. So option A is the best. Option A is correct. All right, let's do one more. One more similar. Okay, the same equilateral. So very similar to what we did earlier. All right. This triangle, the three sides equal each other. The three sides are three diagonal of the three faces of a cube. A cube is six faces are congruent. Okay, quick questions congruent, exactly the same. So option C is correct. All right, done. Okay, let's take your attendance. Unless you have any other question. Let's see over here. My computer died. Christian Wong, he's in this class. Yeah, he's in this class. Why show up so late? Anthony Anderson. Anthony Anderson, I thought he came in. Anthony Anderson, are you here? Okay, maybe they have computer problem. All right, let's take your attendance, you guys, and then we're done for the day. Here we go. Abraham, are you here? Abraham. Abraham, are you here? Okay, he's not here. Anthony Anderson, show up late. Saramban. What happened, Anthony? Okay. Um, do the best we can, but we have a Zoom bomb. Rena Canas. Joseph Cape Cool. Okay. Edward Chu. Edward Chu. If you want to retake your test, you have to do it fast. Time's up. 3 more weeks. Is that 3 more weeks? Today is May 6th. May 27 is your final. Christina Cruz. Thank you. Rick Miguel. Okay. Edron James. Okay, I'm gonna update it. Rick Miguel, that's okay. Lynn Abadan. Thank you. Alexandra. Lincoln Marcel. Okay. Kaleo Lipton. Okay. Nicola Mendoza. Thank you. Libni Murillo. Okay. Amina Nash. Chia Dikama. I see you. Alice OC. Alice OC, is that one or two tests you did not take? Is that right? You okay? You did. I did not update it. Okay, I'm gonna do it right after class. Dennis Alberto. Dennis Alberto, are you here? All right, Dennis Alberto is not here. Derek Pinel. Derek Pinel, are you here? Yes, he's sleeping somewhere. Diana. Diana. Diana, yesterday I saw that you show up on the office hour, and what happened? And then you disappear. So it, oh my God, 12:02. I was like late 2 minutes. I saw you there. I log in, and then you just disappear. You cannot wait for like 1 more minute. I'm sorry. I know. Donovan, Julian. Yes. Okay. If you need anything, stay behind, Diana. Shani Silva. Shani Silva. Jordan. All right. Catch up with your homework, Jordan. Mary Tabia. Havela is here. Christian Wong here. And Christopher Koo right here. All right. You guys, do your homework, your test tomorrow. If you need help, stay behind. Bye-bye now. Bye. Yes, I got you, Derek. Bye-bye, Jordan. Do your homework. Thank you. Oh my God. Here we go. What's up? Okay, if you stay behind, let's do it together now. Okay, let's do it together. Let's do it otherwise. Otherwise, Nicola Mendoza. Let me go over here. This is algebra 2. Let me take care of. Somebody dropped out already. Let me take care of Alice OC. Alice OC. Hold on. Oh, I did not